Have you ever wondered what secrets lie on the surface of Mars? From ancient rivers to mysterious methane, Mars is full of surprises waiting to be uncovered. Join us as we dive into the mysteries of the red planet. Mars has fascinated humans for centuries. Its reddish glow in the night sky has sparked countless stories and scientific quests. But why is Mars so important to us? Exploring Mars helps scientists understand major climate changes that can transform planets. It also lets us search for signs of life, both past and present. The more we learn about Mars, the better prepared we are for future human missions. One of the most striking features on Mars is Olympus Mons, the largest volcano in the solar system. This massive shield volcano stands about 16 miles high, nearly 3 times Mount Everest's height. Its base is roughly the size of the state of Arizona, stretching 374 miles across. Unlike the explosive volcanoes we often think of on Earth, Olympus Mons was formed by lava flowing slowly down its sides, giving it a broad, gently sloping profile. The last eruption occurred around 25 million years ago, and some scientists believe it could still be active today. Another incredible feature of Mars is Valles Marineris, the largest canyon system in the solar system. This canyon stretches over 2,500 miles long, 120 miles wide, and up to 7 miles deep. That's about 10 times longer and 5 times deeper than the Grand Canyon on Earth. Scientists believe that Valles Marineris formed due to tectonic forces as the crust of Mars stretched and cracked. Over time, erosion and possibly water flow further widened and deepened the canyon, creating the vast system we see today. Mars also has polar ice caps at both its north and south poles, known as Planum Boreum and Planum Australe, respectively. These ice caps are made up of layers of water ice and dust, with a seasonal layer of carbon dioxide ice that forms in the winter and sublimates in the summer. The presence of water ice is particularly exciting for scientists because it suggests that Mars once had a much wetter climate. These ice caps could be key resources for future human missions, providing water for drinking, growing food, and even creating fuel. Mars wasn't always the dry, dusty planet we see today. Scientists have found strong evidence that water once flowed freely on its surface. NASA's Perseverance rover recently captured images of what appears to be an ancient riverbed in Jezero crater. These images show curved layers of rock that suggest a deep, fast-flowing river existed there billions of years ago. The size and shape of the rocks indicate that this wasn't just a gentle stream, but a powerful river carrying large amounts of debris. Orbital observations have also revealed numerous dried-up riverbeds across the Martian surface. Scientists estimate that about 1/5 of Mars was once underwater. This includes not just rivers, but possibly even oceans. The presence of fan-shaped deposits, like river deltas on Earth, provides further evidence of Mars' watery past. While most of Mars' water history is ancient, there's intriguing evidence that small amounts of liquid water might exist on Mars today. Scientists have observed dark streaks on some Martian slopes that appear and disappear with the seasons. These features, called recurring slope lineae, RSL, were first noticed in 2010. In 2015, NASA announced that these RSL contain hydrated salts, which strongly suggests the presence of liquid water. However, this water isn't pure. It's likely very salty, which allows it to remain liquid in Mars's cold, low-pressure environment. While this discovery is exciting, it's important to note that the amount of water involved is probably very small, and it may only exist briefly on the surface before evaporating or freezing. The presence of water on Mars, both in the past and potentially in small amounts today, has huge implications for the search for life. On Earth, where there's water, there's usually life. So the evidence of ancient rivers, lakes, and maybe even oceans on Mars raises the exciting possibility that life might have existed there billions of years ago. Even the possibility of small amounts of liquid water today keeps the door open for potential present-day microbial life, although this remains highly speculative. For future human exploration, understanding Mars's water resources is crucial. The Martian atmosphere. Mars's atmosphere is incredibly thin compared to Earth's. The atmospheric pressure on the surface of Mars is less than 1% of what we experience here on Earth. This thin atmosphere is composed mostly of carbon dioxide, about 95%, with small amounts of nitrogen and argon, and trace amounts of oxygen and water vapor. Unlike Earth, which has a rich mix of nitrogen and oxygen, Mars's atmosphere cannot support human life without significant technological intervention. One of the most dramatic features of the Martian atmosphere is its dust storms. These storms can range from small, localized events to massive storms that cover the entire planet. For example, in January 2022, a dust storm nearly twice the size of the United States blanketed Mars' southern hemisphere, causing NASA's InSight lander to enter safe mode due to reduced sunlight reaching its solar panels. These global dust storms can last for weeks or even months, significantly impacting the climate and surface conditions. The dust particles are so fine that they can stay suspended in the atmosphere for long periods, turning the sky a reddish, tan color and reducing visibility. Mars's atmosphere was not always as thin as it is today. Evidence suggests that Mars once had a much thicker atmosphere that could support liquid water on its surface. However, over billions of years, Mars lost most of its atmosphere to space. This loss is primarily due to the lack of a strong magnetic field, which on Earth helps protect our atmosphere from being stripped away by the solar wind. Without this magnetic shield, the solar wind gradually eroded Mars' atmosphere, causing it to lose significant amounts of gases like carbon dioxide and water vapor. This process transformed Mars from a potentially habitable planet with a warm, wet climate to the cold, dry world we see today. Potential for life. NASA's rovers such as Curiosity and Perseverance have been instrumental in uncovering evidence that Mars may have once been habitable. These rovers are equipped with advanced instruments that analyze rock and soil samples to determine their chemical makeup. For example, Curiosity found ancient organic molecules in 3-billion-year-old sedimentary rocks in Gale Crater, suggesting that Mars had the necessary ingredients for life in the past. Additionally, the presence of clay minerals indicates that water was once present, creating a potentially habitable environment for microbial life. The discovery of subsurface water on Mars opens exciting possibilities for microbial life. Water ice has been found just below the surface in various locations, and there is evidence that liquid water might exist under the polar ice caps or in underground aquifers. These environments could provide a refuge for microbial life, protected from the harsh surface conditions. Experiments have shown that certain Earth bacteria, known as halophiles, can survive in high-salt, low-temperature environments like those on Mars. This raises the possibility that similar microbes could exist on Mars today. One of the most intriguing findings on Mars is the presence of methane in its atmosphere. Methane levels have been observed to fluctuate with the seasons, peaking during the Martian summer and dropping in the winter. This seasonal variation suggests that the methane could be produced by biological processes, although geological processes like water rock interactions are also possible. The source of this methane remains a mystery, but its presence hints at the potential for microbial life beneath the Martian surface. Unusual geological formations. The face on Mars is one of the most famous and debated features on the planet. First photographed by the Viking 1 mission in 1976, this rock formation in the Cydonia region appeared to resemble a human face. However, subsequent high-resolution images from the Mars Global Surveyor and Mars Reconnaissance Orbiter revealed that the face is simply an optical illusion created by shadows and light angles. The formation is a natural mesa, like those found on Earth, and does not indicate any artificial structures. Recurring slope lineae are dark streaks that appear on Martian slopes during warmer seasons and fade away in cooler months. These features are thought to be caused by the flow of briny liquid water or dry granular flows. The presence of hydrated salts in these streaks supports the idea that liquid water may be involved, albeit in very small amounts. Understanding RSL is crucial for determining the current water activity on Mars and its potential to support life. Human exploration challenges. One of the biggest challenges for human exploration of Mars is radiation exposure. Unlike Earth, Mars lacks a strong magnetic field and thick atmosphere to shield against cosmic rays and solar radiation. Astronauts traveling to and living on Mars would be exposed to higher levels of radiation, increasing the risk of cancer and other health issues. Developing effective shielding and protective habitats is essential for ensuring the safety of future explorers. The psychological effects of long-term isolation and confinement are another significant challenge. A mission to Mars would take several months, with astronauts living in close quarters and limited contact with family and friends. This isolation can lead to stress, anxiety, and other mental health issues. Preparing astronauts with robust psychological support and strategies to cope with isolation will be crucial for the success of long-duration missions. In this video, we've explored some of the most fascinating mysteries of Mars, from its towering volcanoes and vast canyons to the elusive signs of water and potential for life. Ongoing missions like those of the Curiosity and Perseverance rovers continue to uncover new clues about the red planet's past and present. Future missions, including those planned by NASA and other space agencies, aim to delve even deeper into these mysteries, paving the way for human exploration.